Couple of years ago, I accidentally became the semantic kernel guy. Semantic kernel looked interesting to me. It was very new. Everybody was starting to do AI, and we jumped on the bandwagon. And initially, everything was calling HTTP services and coding things by hand, text merging our prompts together. Um, and I was looking for something else, and there was this thing called LangChain, and it was really interesting. And that's kind of fallen out of favor now, but semantic kernel turned out to be a really good bet. So let's talk about it and why you should be looking at it if you're building something like a Copilot app, or even if it's not a Copilot app, if it's something to do with even machine learning sometimes. Behind the scenes stuff. Let me tell you a little bit about me. My name's Mike Yeager. I'm the CEO of Code Consulting. So we do custom app development and consulting engagements. I worked my way up as a senior developer and a manager. I do a lot of AI projects, writer and speaker. I like to ski. So that's me. And I'm part of Code, and Code just turned 30 last year. So we're very proud of that. We've been around quite a while. As I said, I'm in the consulting division. We also do staffing, very different kind of staffing from what you're probably used to. Most people really hear the word staffing and go, so we're doing a much different take on that. People really enjoy being part of the staffing. So if you're interested in that, you can talk about that. A lot of you probably get Code Magazine. At the end of this, I'll show a slide where you can get a free subscription for a year. It's a mainly Microsoft.NET Stack developer magazine, but it covers everything, not just that. And then we do training. So either customized training or training for, like this that's free, or organized training where we do things like, show you how to use Blazor. I just want to point out that we do have AI consulting services, and this has been a big thing for us lately. So I wanted to give you these links. We do our stuff off of codemag.com, so you can do /AI or /executive briefing. Now, executive briefing is where we come in and talk to your C-level people and above, and essentially answer all their questions and get them on board. It's amazing when we go into these briefings, they get very excited, and it tends to make projects go forward. So we found that that's very effective. If you're interested in AI and want to get it going, having support from the top seems to really help. So that's a good way to do it. Get us involved at that level. What are we going to talk about today? What is semantic kernel? Why should I use it? Why should I use any framework? Which frameworks are out there? What's in them? So we're going to talk about all the different parts of semantic kernel, a little bit of how it was built up into what it is today. I find it very effective, and then maybe where it's going in the future. So we'll talk about that a little bit as well. So let's get started. What is semantic kernel? It's a framework. They call it an SDK, but I think of it more as a framework. And Microsoft created it a few years ago for working with large language models, small language models, vector databases, all the things that you do with AI work, especially generative AI work. Microsoft developed it internally for their copilots. So all of their copilots were originally built on this, and they're starting to change that a little bit, and I'll talk about that in a future slide. So why a framework? Why do you want to do semantic kernel? Why am I saying you should do semantic kernel? It allows you to handle things in a more generic way. It abstracts things. It does what frameworks do. So if you are building a website, you're probably not going to make a website with just HTML and JavaScript and CSS. You're going to use some sort of a framework like Angular or Vue or React. And same thing here. When you deal with models from different places, when you deal with different models, when you deal with different vector stores, all of these things, hand coding them just doesn't work out very well. And what has worked out very well is handling them in a more generic way. So we can abstract things away. It's less code changes down the line, and it helps us do all the things that we need to do in an AI project. So which ones do we care about? LangChain for a long time was the big kahuna. That was the one that everybody was talking about. It was mainly in Python. They also had a JavaScript and TypeScript version. And it was this client tool that allowed you to do the things that we were talking about. It's been losing favor a lot lately. People were using LangChain, and this is great. I can get going very quickly. I can do some things that were difficult to do by hand. But they found that as they were getting into more and more mature projects, and the projects were getting bigger, and they needed to do more esoteric things beyond what the starter project could do, that they were sort of fighting the framework more than anything else. And that's something that I haven't found with Semantic Kernel. So Semantic Kernel will occasionally still go and write some handwritten code outside of the framework because it doesn't yet support something new, but it doesn't really get in our way. I found that it actually works really well. It's in .NET C#, which is what I'm going to talk about today because that's what I mainly use, but it's also in Python and Java. So if you're developing things in Python, and that's a great language for doing things quickly and trying things out, you can reuse a lot of that stuff in a C# application, .NET. And why is that important? Because a lot of things are sort of put together initially in Python. So let's try this out. Let's see how it goes. Let's train some models. Let's do this. Let's do that, which has been, fantastic. But then putting that into production, Python in production has not traditionally been a big win, especially in the enterprise space, where, it's like, okay, how do we put this out there? Well, we're going to make Docker containers and scale it up with Kubernetes, and everything's going to be done in Python, and we're going to have to maintain that stack. And so a lot of infrastructure has been done in .NET, and that's what a lot of enterprises are used to. And it's got some really nice features where you don't have to do things like spin up Kubernetes clusters necessarily. You can do things as platform apps and just say, I just want to deploy this. I don't really want to care about maintaining all of my my Docker containers. So it's pretty nice that you can reuse things across .NET and Python, and if you're a Java developer there as well. It's become very mature in the last couple of years, and they're working on it constantly. There's a lot of things going on. So very exciting. The new thing is Microsoft Extensions.ai. And this is sort of like the next version. And right now, Semantic Kernel is implementing this. It's making this part of what's in Semantic Kernel, but it can be used on its own. And the reason that I say this is a little bit more in the future is that even though it's coming along, it mainly right now deals with the Microsoft stuff. And if you want to do other things, it's not as mature. So we'll have to see how that goes. It's also considered an SDK by Microsoft, and to me, it seems more like an SDK. So it's been interesting working with it, and I like that, but it doesn't have all the support that Semantic Kernel does right now for all different things. So if you want to do something like use OpenAI on Azure, it's great for that, because that's Microsoft stuff. But if you want to go use it to do Hugging Face models locally, not quite as good for that. So what's it all about? Well, there's a lot of things you have to do, especially in generative AI. Initially, we had to create these prompts, right? So you would create prompts, and often it would be text right inside your program. And then, well, okay, I got to take the user input and I have to stuff it into this prompt. So we do some basic text merging, where we would say, find and replace, and we'd look for curly braces or something like that. So there's this templating engine. And then what do you do with the prompts? They're just part of your source code at that point. And what if you want to tweak a prompt? So it became apparent that we wanted to handle prompts more as a programming asset, and that templating was a thing. And we didn't just need to do basic text merge, but we needed to do more advanced templating. So we can use templating libraries like Handlebars is a more advanced templating library that's supported by Semantic Kernel. So you can actually template and iterate things in your templates, for example. So that's one thing, being able to store and version control and text merge your prompts. And another is that, one of the big early wins for these generative AI apps was RAG, or Retrieval Augmented Generation. Sometimes they just call it grounding, where if you're asking a question that's not general knowledge, that it's not trained on, say it's on your employee manual, do we get Groundhog's Day off? Then you need to go out and pull the section of your employee manual that pertains to holidays, and you can stuff that into your prompt. And that's essentially what grounding is and what RAG is. You go find something that's in your own world, and you introduce it to the language model, and you say, hey, here's my section of what our holidays are. Base your answer on this, and it'll read that as part of the prompt, and it'll come up with an answer. And so that was very useful. That was a really easy win. And then there was also this idea of tools, and sometimes they're called connectors, sometimes they're called plugins. And what that means is you can hook your LLM up to some programming. So you can say, call a web API or a webhook. Or you can call some custom code that you wrote, and you can describe these things to the LLM and say, I have this thing that does this calculation, the secret sauce in our company, where it takes these inputs and it does the calculation, does the output, gives you the magic number that you need. Call that if you need to. And then the LLM kind of figures out, oh, I need to figure out what this data is. I can pass those in as parameters. I get the answer back, and I can use that in my answer. So there was RAG first, and then there's these tools, connectors, plugins, and sometimes RAG is based on a connector or a plugin or a tool, and sometimes it's not. So that gave us a lot of what we think of traditionally as, a generative AI framework. Then later, the language models got to the point where they could start to do more complex things. So we would ask the models, hey, I need to do something more complex. Come up with a plan first. And the model would go out and say, okay, step 1 is to do this, step 2 is to do that. And then it would follow its own plan. So there was some basic planning. And that planning eventually turned into agents. So agents are this ability to say, okay, here's a large language model. Here is some information that you have, like some RAG stuff. Here's, for example, a set of documents, and you can draw on information from these documents, and we've automated that process a little bit more. And that gives that agent a little bit of a knowledge base to work from. So it becomes sort of a specialist and can use that additional information. It also gets a special prompt. So you're telling the agent, hey, this is your role, this is who you are, this is how you should act, this is how you should be. And then we can give that agent access to some of our tools. So an agent really is a specialization. So if you have, say, web research to do, you might tell the agent, you are a researcher, and your job is to search the internet, and you give it access to a tool. And if there's some special information that it needs to know, some documentation, you can actually do some fine-tuned training on the model. You can do RAG with the model so that it has all of these things to work with, so that it can be the very best it can be at doing research or doing web searches. And then when you ask things that it needs to go out and search the web for, what it does is it hands that off to this agent who has all of this training and access to tools and additional information. And it says, I need you to research this, go do it. And that's the basis of the multi-agent system now. So the idea is that LLMs can be a lot more effective if you have a bunch of these agents all set up to do specific things. Then when you ask it something, it can make use of the agents to go and figure it out. So let's see, what's Semantic Kernel? It's just a NuGet package. Again, they say it's an SDK. Go to the GitHub repo, because not only is the source code in there, but there is also a whole lot of documentation, a whole lot of samples. There are notebooks that you can go and run through. If you haven't done a particular type of thing, I want to use a Pinecone vector database, how do I do that? You may find a sample in there that shows you how to do it. So I would say go and clone the GitHub repo and get all that stuff, because the samples and the documentation are really fantastic, and they're definitely worthwhile. All right, we're going to get to code pretty soon. I'm just going to whip through a few slides just to give you a basis what you're going to be looking at. We talked about one of the main things that this did for you was that it allowed you to, Semantic Kernel allows you to template things, to have a templating engine, to have prompt templates, and to treat them as resources. So one of the first things they did was they said, well, you can put all these, you can organize them into folders, and you can keep a library of them. And initially they started off as, here's your prompt, so that's a text file, and it can have replacement parameters in there, so that you can take user input and merge it with the prompt. And it also has some settings, so things like temperature. So temperature is how creative do you want it to be? If you're asking a science question, you probably don't want it to be very creative, but you're asking the LLM to make poetry, you probably do want it to be fairly creative. So settings like that can go into the configuration. And now these things are in source control. So I can check this prompt in, I can version control it, and Semantic Kernel makes it easy for me to use these files. There are other ways to do it now. You can also just store these together, the configuration and the prompt and some documentation in Markdown format, and you can store those in YAML files. So that's another way that it handles, and we'll actually look at something called Prompty in a minute that is sort of an evolution of that makes them a little bit more useful. So you've got this ability to have your prompts and all the settings that are associated with them and reuse them and pull them up when you need them. You also have this ability to write your own code. And I can write a function in C#, for example, and I can put an attribute on it and say, hey, this is available. And I can describe it and say, this function does this. Here are the parameters that you need to pass. Here's what it gives you back. Here's what it's useful for. And that description can be used by the LLM. And this is when we were talking about tools. It can actually use that. So a plugin, a function, a tool, very similar things. And it makes no distinction between semantic functions, which are prompts. So the semantic, the speaking or talking with a prompt to do something, which is kind of a new way of programming, and C# code. And I can call either one of those things as a function and get some work done. So I can write my own code to go off and add something to a database or send an email or do whatever I want to do in code, go out and do a web search, for example. Or I can have a prompt that does something that says, oh, write me a poem about something. And that's a new kind of programming that we really couldn't do before. And so now these two are really similar in concept, and you can do one or the other. So here's just a quick example. So here's the prompt text. Generate a creative reason or excuse for a given event, be creative and funny, blah, blah, blah. And you can see at the bottom, I have a little section there where I can text merge something from the user so that I can reuse this prompt. What goes along with that is the configuration. So the configuration is things like the description. The description is pretty important because, as I said, the LLM could read that and could decide to use this. It can say, oh, I've got this prompt that I can use to turn a scenario into a creative or humorous excuse to send to my boss. Well, if that's something that I ask the LLM to do, it could invoke this tool. And now I've got some settings that kind of go with that. And I'm not going to get into all the different settings here, but it basically kind of fine tunes how the LLM processes your prompt. So Prompty, this is a standard format, and there's a web page here. Some guys at Microsoft worked on this, which is really cool, is that it works in Semantic Kernel, it works in LangChain, it works in Prompt Flow, it works in VS Code, it works in Visual Studio, it works in Azure AI Studio, Foundry. So you can make these prompty things. Again, it's one sort of file that contains Markdown, it contains the prompt, it contains the settings, it can contain other stuff, the description. And so you can create these prompts, treat that one file as a piece of source code, source control it, and use it. And you can actually run it in all these different things. So if you have a Prompty prompt, you can pull it out of Semantic Kernel, use the same one in LangChain, test it in VS Code. I'll show you an example of that in a minute. So it's a really handy tool. So here's just a real quick example where I've got, you can see the prompt is in there at the bottom and the settings are at the top, and there's just description and a name and authors and things like that. And here's C# code. So again, I just want to put an attribute on my functions, the ones that I want to expose, and I say this is a kernel function. And then it's very important that I give it a description, because again, the LLM can look at this just like it looks at the descriptions in my prompts and says, this is something I can do for you. If you want to duplicate a string, you can call this, and you pass me an input and I'll return what comes back. And you can get more and more detail on this, so you can put descriptions of the parameters, etc. But that's the basic idea. So we're going to look at code in a minute, and we're going to talk about inline functions. That's where you just do something on the fly. Templated functions, that's where we're pulling templates off of disk in one format or another and loading them up. Native functions, that's the C# code, and Prompty. All right, so here is my project, and we're going to just jump into some code here. Just give you a quick idea of what's going on. I've just got all these settings. So I have a few different endpoints, so different models that I'm hitting. And all my configuration is in my app config, and I read those in. But essentially for each one, I need to know the endpoint, an API key to get to that endpoint, and which model or deployment of a model I want to use. So in this case, it's GPT-4. This one is for text-to-speech, which I'll show an example of in a bit. So you can write something out and it says it out loud for you. Whisper is the opposite. That's where it reads an audio file and turns it into text for you. So I'm using different models for different purposes, and you'll see even here we're using DeepSeek. That's one been in the news quite a bit lately because it's inexpensive, performs really well. So what I'm doing in my main is reading all that information in, and then I do my first thing with Semantic Kernel. So I'm going to create a builder. So this is very much like when you build an ASP.NET website. You have this builder and you put all the pieces together that you want to use in the website. Here, we're putting all the kernel pieces together that we want to use. And I can create different instances of different builders to do different tasks. So this particular one, I'm going to say create a new builder, and I'm going to add a few different things to it. The ability to do audio to text. So Azure OpenAI model and that's my Whisper deployment. So I'm pulling in those settings from above. And I'm also going to do chat completion. So this is what you're used to with ChatGPT-4. So this kernel is going to have the ability to do these different things. Also text to audio. Now in the early examples, I'm not going to use the audio to text, and I'm not going to use the text to audio. I'm just going to use the chat completion, but I can build those into my kernel. And then I can call build on it. And the reason that I don't call build immediately on here and just get a kernel back is that if I want to do logging, if I want to see what's going on, I have to actually add that separately. So I have to create my builder, get that set up, and then add logging to it before I can actually build it. And I'll show you some of that in a minute. So that's the kernel. That's the thing that I can use to do whatever I need to do in my code. And then we've got, I'm just going to clear the console just so that we start with this is all just command line. So this is just a basic application, as basic as I could get to show you how to build these things. So I clear my console and then I call my first function. So the first one is an inline function. This is sort of like hello world. And I'm going to show you all the pieces of putting something together. So I have my prompt. In this case, I'm just declaring it in code. I'm saying there's an input, a variable here that I'm going to replace, and I'm going to say rewrite the above in the style of Shakespeare. Okay, pretty simple prompt. What do I want my settings to be? I want this to be fairly creative. So instead of just using the default settings, I'm going to set the temperature relatively high. That's a setting between 0 and 1. So I'm going to say 0.9, be creative. And then I'm going to load up my function. So I'm going to take my kernel and call this method on it, create function from prompt, and then I pass in my prompt and my config. And this is the thing we saw earlier. These can be in files, but in this case, I'm just creating this right here in code. I'm saying load this up, make me a function of these two things. Put that together, and then I need to pass arguments. So there's a thing called kernel arguments whenever you want to pass arguments in. And I have this input argument up here that I'm going to need. So I say this is my input, and then in this case, I could get it from the command line or wherever. I'm just going to put something in there. I'm so fascinated by all the AI technologies. And then I'm going to go ahead and invoke that. So I'm going to use my kernel and I'm going to say, I want you to invoke this function. So this Shakespeare function is just a local variable that I said, load up a prompt and a config, make a function out of it. So I asked my kernel to do that. And then I'm going to say, execute this function with these arguments, and then write out the results. So let's see how that works. And it's a little slow with the recording going on, but I'm going to go ahead and load up the kernel, and it says, verily, I am entranced by all manners of technologies wrought by artificial intelligence. So that was rewriting in the voice of Shakespeare. Rewrite the above in the style of Shakespeare. And this is what I passed in as my argument, and that's what came back out. So that's the very basic thing that I did. I created this kernel. I gave it some capabilities when I created it as part of the builder. And then I am just, saying, okay, well, I'm going to invoke this function. There's my prompt. I did it in code, but I did it in a very standardized way. Now, if I wanted to change, and it's using the chat completion for this portion, if I wanted to change, say, which model I'm using, I could just go in here and change my chat deployment. And it would use a different model that's deployed on that same endpoint. If I wanted to go to a different endpoint, I could go ahead and do that. And that's something that I do fairly commonly. I'll have different models running on different endpoints, and I'll use them for different things. So what's nice about this is that I have this really standard way of putting this together, and I'm not writing to some interface for one model that's hosted in Azure and another model that's hosted in OpenAI and another model that's hosted on Hugging Face and another model that's hosted in DeepSeek. So that's pretty nice, and that's one of the reasons that it's really good to have this kind of a setup. All right, so inline functions. Let's go to basic functions. So this one is a little bit more interesting. It's one step up. So I've got these plugins. This is what I showed in the slide earlier. So instead of doing all of my configuration right in my code and saying, I'm defining my prompt here, I can have all of these, and this is just one way of creating this library of prompts. I can have the text for the prompt here. So we can look at, say, if I'm doing an excuse. So this is the prompt. These are the config settings with it. Again, I could do these as one file, as a YAML file. I could do them as a Prompty file. But now I can actually have somebody work on the prompt. They can tweak the prompt. We can version control it. And all I have to do is load them up. So I'm just going to go, in this case, I'm reading them off of disk. I'm going to say, go get the plugins fun folder. And I want to load all of that up. So when I do this, I'm actually loading everything in this folder. I'm loading the excuses, the jokes, the limericks, everything that's underneath of it. So I'm loading a whole section of things at once. So you can categorize these things and set them up and say, I want to load all of these prompts. And then all you have to do is say, create plugin from prompt directory, and that loads it into the kernel. So unlike before, where I was just saying, here's my prompt, just make me a local variable that represents that function, I'm actually loading these things into the kernel itself. So how do I use it? Most of this code you'll see is actually right line, so we can see something coming out on the screen. When I actually call the function, because I'm saying load all of these plugins, it just makes me a nice little dictionary of all the plugins that it's loaded. So I've got one for each of the subfolders there. So if I want to call the excuses plugin, this set of 2 files, the configuration and the prompt, I can just manually say that's the one I want to call. And I can pass in my input. So same thing we saw before, passing in arguments in a specific way. So every argument has a name and the actual value. And that's really all that's going on here is this invoke. I'm saying I want to invoke a particular function, and here are the arguments that I'm passing. And then it's going to write it out. So in this case, I'm doing 3 in a row. I'm calling excuses and tell me a joke and do a limerick. And here's an example where I have multiple arguments. So a name and a subject. So they're not named input at this in this instance. And so when I call the limerick, it's going to write a limerick about Mike, and it's going to talk about airplanes. So let's go ahead and give this a run. And now it's running. So this is making a call out to Azure, and it's using an LLM that's up there. And I'm saying, give me a lame excuse. And again, this is a prompt template that I'm using, and I can tweak that template to get results. I can use this in testing, so I can write tests, have it generate some answers over and over again. I can grade those answers. I can tweak my prompt to get better answers if they're not as good as I'd like. You can see in the limerick here, there once was a fellow named Mike, and talks about being in a plane. So it's taking my parameters that I passed and using them as it's developing things. So this is a whole lot nicer than all of the code that we would write by hand to do all of these same things. Okay, we talked about native functions, and I want to show you one of those real quick. So this is what we looked at on the slides earlier. Again, very important that you put the kernel function attribute on here to tell it that it's available to be used by the LLM, and then the description. It's important that you tell it what it does. You can also put attributes, descriptions on the input and output, so you can be quite wordy with that, tell it what it does. So I have this method called QWERTY, and it just returns all the letters on the top line of a QWERTY keyboard, and another one called dupe that takes an input, duplicates it. So this is dead simple. This is the most basic thing I could think of. But you can do whatever you want in here. Anything that you can code in C#, you can make available to the LLM to use. So let's look at a very basic native functions. And I am going to do something similar to what I did when I imported all of these plugins, the semantic plugins. I want to create plugins from a type. So I'm going to say, here's my class. Anything that's got that attribute, pull it in, pull in the descriptions, load those up, make them available. And then I can call them just like I did before. I can say I get a collection of them. So whether it's loaded off of disk or whether it's loaded by loading code in from an attributed class that I have, I can invoke that. I can pass in parameters. So the first one is not taking any parameters. The second one is. So again, same call. I call things in the same way. It doesn't matter if it's a prompt or if it's C# code. So go ahead and call this. And here's my output. So there's my QWERTY IOP and there's my hello, hello. So I duplicated the word hello, which is the parameter that I passed in. All right, all very nice, but still kind of basic. Let me go back to the slides for a minute and we'll talk about taking this up a step. So again, RAG, I'm not going to do a RAG demo right now, but RAG is a way to provide better context. So you know, prompt can only be so big. You can't throw tons of documents into it and have it digest all those documents and give you an answer. It's very slow. It's very expensive to do things that way. So the idea is you go find the piece that's relevant. You put that into the prompt. Your prompt stays relatively small, and it's got all the information that it needs to answer the question. And usually if you do that, it'll give you the right answer. If you say, here is the relevant information, base your answer on this, literally a prompt that simple, it'll work. So there are different types of RAG that we should talk about just a little bit. There's a lexical search or a keyword search. So when you do something like a SQL full text search, or you have something like Elasticsearch or Azure AI search, those can use a keyword search. And they have some cool advanced features in most of those systems that will allow you to do things like set up dictionaries of words. Like if you're searching for the word car and instead it has automobile in there, you can have these dictionaries that say, well, if they ask for car, also include automobile or include vehicle. So there's some fancy things they can do to make that work better, but it's really good when you're looking for specific terms. So if you're searching for very specific terms, that's a great way to do search. Then there's this thing called semantic search, and this is, you've probably heard about vectors and embeddings. And what that is you take some information and you encode it as an array of numbers. So that's what they call a vector or an embedding. And for example, you can say, here's a sentence. I want you to encode this sentence, and it'll encode it into an embedding. So what's an embedding? It's an array of numbers. Let's say that we do our embeddings of 1536, which is a common size. So it has 1,536 different things that it tests about that sentence. It may do things like color. Does it mention color? If so, is it more blue or red or orange? And that may be one slice. That's maybe the first thing in the vector. Emotion. Does it talk about physical things, person, place, or thing? Is it talking about plants? So they figure out how to create these embeddings. So they use an embedding model, and it says, I have 1,536 or whatever different things that I'm going to rate this sentence on. And it comes up with those 1,536 ratings, puts them into an array. Great. What do you do with this? Well, turns out when you want to ask about some information, you ask in English, and we can take your question and run it through the same process, create this embedding, which rates it in these 1,536 different ways. And then we do a search between those two embeddings. So we find the distance, we figure out how close they are. And it turns out if you're talking about similar things, you get similar results. If you're talking about very different things, you get very different results. So the closer your question is to the sentence that was, encoded earlier, the answer, the closer these searches are going to be. So that's an interesting way of looking for things based on meaning. And, if I'm talking about swimming pools, I can do anything that's even related to swimming pools is going to be closer than anything that's talking about, say, vehicles. And it's not specific words that it's looking for, but it's looking for sort of the underlying meaning or the semantic meaning of what I'm talking about. So that's just quickly what semantic search is. And then there's this thing called hybrid search. And what they found was that some things work better with a keyword search. Some things work better with a semantic search. And if you do both searches and then take the top results from both of those and re-rank them, you get even better answers. So that's a very popular thing to do now. Another way to do it is knowledge graphs. And that's really when you have relations between things. So think about, me, Mike Yeager. Well, I work for Code, and Code has other people that work for it. So I'm sort of related to those people by that. I also have a family. I also live in New Mexico. So all of these relations can be built up in what's called knowledge graphs. And if what's important is the relationships and not necessarily the keywords or the semantic meaning, you can search on knowledge graph. And you can combine these in different ways for different purposes. So you really have to figure out what is it that I'm trying to do. What's the best way to find that information so that I can get a really good answer out of this? If I pull back, if I have a question that talks about, people that maybe I work with, then maybe a knowledge graph is a better search than a keyword search. So you have all these things available to you. The idea is that you go pull that information back. If it's the correct information, you feed it into the prompt, and the LLM is going to give you a really good answer. Another way to do RAG is just SQL queries. If I'm asking about order history, I may have a client and I just want to know something about that client, like what did I do in total sales with that client? I may need to go and do a SQL query against my database, pull that information back. I can inject that into my RAG pipeline, stick it into my prompt, and then I'm going to get an answer back that has that information. So I can do some really interesting things. Plugins, tools, functions we talked about. There's a lot of them out there that you can make use of. So everybody's got these things, and think of webhooks. How many different webhooks can you hook into? This is how Microsoft works with Copilot. So they say, well, we can use all of your information. We can look through your emails. We can look through, and not someone else's emails, but the documents that you own. And they do that through Microsoft Graph. So they can hook into Microsoft Graph and say, look through all this stuff, index it, figure out, use it as part of the answer. So you have all these third-party things that you can hook into. And then OpenAI came up with this function definition. So it's sort of a guide, and that was sort of the next step in this. It says, this is how you make functions so that you can call them. Now, Semantic Kernel, as I said, has this way of doing that. But when OpenAI came up with this structure for it, they said, well, we'll just support that. So if you have any function already defined out there that supports this, you can just use those as well. And lately, there's this thing called Model Context Protocol, or MCP. And it's just this way of wrapping a thin wrapper around tools and functions so that you can call them in a uniform way. So you can actually serve these things. So you can have an MCP server, and you can make a whole set of things available on that server that are allowed to be used. And you can have a client that connects to the server and uses those tools. What's interesting about MCP is that it's doing what we could do before, but it also makes it available to list all the tools and have catalogs of tools. And so now you can have these giant catalogs and say, well, I need to do something. I need to find a tool that does that. So you don't necessarily have to say, well, I have a tool here. I'm going to load this for you and allow you to use it. You can say, can you find a tool that will do what I need? So it's commoditizing these tools a little bit more. So that's what's kind of interesting about MCP. And then what we've done so far with calling tools and functions is that I've loaded one up and I said, I want to use this function, and I would call it, and I'd pass in the parameters. But LLMs are pretty smart, and they understand English and they understand other languages, and you can talk to them and say, I want to do this. And it can figure out, oh, I need these parameters. Let me see if I can find them. And it can ask itself, do I have this information? So there's this thing in Semantic Kernel called automatic function calling, and it automates the entire process for you. So you're going to call the LLM, you're going to ask it some question, and it's going to say, oh, you know what? I have this tool I could use. And I'm going to go ahead and invoke that, and I know how to do that. I'm going to do it for you. And if you're thinking about OpenAI, there's this whole process where I wrote some C# code. It lives here on my machine. Now I'm making a call to this LLM that's up in the cloud. How is the LLM going to invoke my method? Well, I've got to orchestrate all this. The LLM has to call back and say, I want to make this function call that you told me about. Here are the parameters. And then it makes the call, and then that information gets returned to the LLM, and then the LLM makes use of it. And there's this whole song and dance going on. Semantic Kernel made that relatively easy. So let's take a look at what that looks like. Automatic function calling. I am going to just show you this code. And I've done just what I did before. I took my kernel, I imported these plugins from my C# object. So I've got my two function calls, the QWERTY IOP and the dupe call. And I'm saying these are loaded up. And then I have my prompt, and I'm just saying, be brief, don't add any formatting to the output, duplicate the following string. And in this case, I'm just doing that in line. And then I'm creating the function from the prompt. We've seen that before. I'm not passing in any settings, just using the default settings. And then I'm setting up a configuration. So when I make this call, I'm saying auto invoke kernel functions. So any function that I've loaded up, I want to go ahead and make that available, and you, LLM, can call that function if you want to. And then I have my arguments. So now when I call invoke async, I say, this is the function I want to run, my prompt from above. Here's my argument, go fishing. And it's going to be able to say, I've got this tool that I can use to duplicate this. Now, an LLM may be able to duplicate this on its own, but then again, it may not. If I have something that's specific to my business, some process that I need to run, you can see where it would make it very easy to go ahead and do that. I just load it up, and then as part of it, when it needs to run that process, it runs that process. So here we've got go fishing, it duplicated it. Well, what actually went on? I'm going to go back up to my builder here. And remember the builder where I put in my chat completion, and I'm using my GPT-4o completion. I'm going to turn on logging, and I'm going to set it fairly high to the trace level, and then I'm going to run this again. So this is a good way where you can see what Semantic Kernel is doing, what's going on. And it just uses the same logging, the dependency injection stuff that is available everywhere else in .NET. So now I can see what it's doing under the hood. And I can see that it's got some functions. So it loaded up 2 functions here. These are my 2 functions. And it's taking input, and then it looking at the prompt, and then I can see that it goes and it actually calls my function. So I can see step by step, and this is really showing a lot of info, everything that it's doing. And I get things like duration, and I can see that it's, calling the function as I expected. So that's what it's actually doing. All right, I also said that I was going to show you a little bit about Prompty, and I'm not going to show that here because there is an issue with it. But what I am going to show is VS Code. So this is an extension for VS Code called Prompty, and I've got it loaded up in my machine. And I've taken one of these prompts and all of the settings, and I put them in this newer format. So this is like a YAML format. And I can actually put Markdown in here. So I've got my settings combined with my prompt, and I've even got some sample data, parameters. So I've got a subject and a style that are going to get replaced in my prompt, and I can say, here's the sample data I want you to use when you run this. So now I've got my temperature again fairly high. I can set things like how many tokens do I want it to use. I can tell it which configuration I want to use. And some of that can be set in your settings for VS Code. What's nice about this is that I can try this interactively. And I say, why did the squared answer go to therapy? Because he couldn't stop do-si-doing in circles. Yeah, not a great joke, but I can mess with my prompt now, and I can just try this over and over. So I can run this. This is one of the run times that's supported. And then I can use the same asset in my semantic kernel. Now, I can't really show it to you because as I said, there's a bug that I'm working out with the semantic kernel team right now. But that's kind of a cool thing to be able to put everything in one big YAML file and have descriptions, and basically the README is in there along with the settings, along with the prompt. And so that's just kind of a nice thing. So we're gonna go ahead and skip over that and talk about agents. So agents are all the rage. Everybody's doing agents. I told you briefly what agents are. You essentially give this LLM a personality. So you say, I'm going to use GPT-4o. I'm going to give it a specific prompt that says, you are a researcher, for example. And I can tell it how I want it to act. I want you to be overly nice. I want you to be very precise. I want you to be specific. I want you to be whatever. You can make tools available to it, and you can give it a certain amount of information, like RAG. You can say, here's a bunch of documents that I want you to be able to have access to in a RAG fashion so that you have all this information. So maybe it's my employee handbook, and my agent is going to be an HR agent. And I can tell it, these are all the rules, so I can make up a prompt. I can maybe fine tune that model. I can fine tune a version of 4.0 so that I sort of ingrain some behavior in it, like, it's HR, so you don't want it swearing, and there are some guardrails for these things, but a lot of times you'll end up putting this in the prompt. And so your prompts will get really big, and you have a lot of very specific things. If you're asked about this, then say that. So what you can do is you can take a lot of that and just train the model with that. And it'll start behaving that way. So that's a little extra training you can do. That's one of the reasons that you would do some fine tuning on a model, so that it understands that, oh, I should always act this way. But you don't have to do that. And in most cases, we don't. We just say, here's the prompt that tells it how to act. Maybe here's some documents that you can make use of in a RAG sense, and here's some tools that you can use. And now we've defined an agent. So now I've got this agent that can be used in various ways. It's sort of like a reusable piece of code. So let's take a look at agents. And you'll notice I've got a few of these pragma warnings on here. These are for things that are still not released yet. They're in alpha or pre-release or beta. And by putting that on here, it allows you to use them. So that's what those are for. And the chat stuff is still fairly new. Not all of it has been released yet. But I want to show you how I set up an agent. So in this case, I have a program manager, a software engineer, and a project manager. And I'm going to make an agent that is specific to each of these functions, and I'm going to allow them to work together to do a complex task. So I have a prompt for each one. You're a program manager, you take the user requirements, you create a plan for creating an app. I'm telling it how to act. I'm not giving it access to any particular tools or documents. In this case, this is the simplest example I could think of, but I could do that. Here's a software engineer, develop prototype using HTML and JavaScript, taking into consideration all the requirements. So I might have called this a JavaScript developer. Program manager. Now I'm going to make an agent out of each of these. So I create a new agent. So again, this is sort of defining a reusable thing, this agent. I'm going to give it a name. I'm going to give it the instructions. I'm going to attach it to one of the kernels. So this is the kernel that I'm using. And this is where I would also give it access to tools, or documents that it has access to. So this is where I'm actually defining what the agent is. And in this case, they are just going to use a regular LLM model, and they're going to have a specific prompt, specific instructions. This is who you are. Then I'm going to set up a group chat. So it's an agent group chat, and I'm going to say these are the agents that I want to participate in the chat. And then this is important, I give it some execution settings. So one of the things I need is the selection strategy. And in this case, I'm using what's called a sequential selection strategy. And I tell it who my initial agent is. So I'm essentially going to hand things off. I'm going to start with the program manager. He's going to be the first guy, the first agent sort of in charge of things. And then it's going to go to the software agent and the project manager agent. And the other thing that's important is a termination strategy. When does this thing end? Because these guys could talk all day. and sometimes they do. So I'm going to say, well, after 10 rounds of going back and forth on things, call it good. Don't just keep going. And I'm also in here going to say who is the guy who terminates. So the project manager is going to be the guy who can say, this is done, we're done. And if we look down here at the termination strategy, and it's should agent terminate async, and I'm just going to show you very quickly. Basically what I'm doing is in here, I'm looking for him to say the word approve. So when he says approve, then we're done. That ends the chat. So I've decided these are my 3 people. This is the guy who's going to start the chat. These guys can talk amongst themselves up to 10 times, and then they're going to output something. So what I told it to do was I want to develop a calculator as a web app, keep it very simple, and get final approval from the project manager. So I'm telling it that's how we end this thing. So I add that as a chat message. So I add it as a user message. That's the input. And I start off my chat. My chat's all loaded up. I've got all my guys in there, my agents, and I'm saying this is how we're going to start. And then I'm just going to output to the screen that the user said that. And then I'm going to wait and do this invoke async. So I'm basically going to, every time there's a turn, one of my agents says something, I'm going to write that out. So I'm going to say who they are, and then I'm going to show the content for that. And eventually this is going to terminate either because it went 10 times or because the program manager said approve. So this one actually takes a little bit, and the startup time on this is pretty slow with all of this recording going on, but these actually work relatively quickly in real life. And once you have these things loaded up and primed, there's not nearly so much of a startup cost. So I've got my tracing turned on. That might make it a little bit difficult to see, but I can see here that my user says this, and then I can see some traces that are going on, and then I can see the project manager talking. And they're going to talk amongst themselves until they come up with something. And it'll take a minute, and then finally the project manager assistant says, hey, that was approved. And that ends the turn. And if I look at this, I've actually got all the code in here. It's not in an easy format to read right now because I've got all that logging turned on, and that's what we're actually seeing is the logging. But if I scroll up just a little bit farther, you can actually see what's been output. And so this has actually come up with a web page with JavaScript, with some CSS that makes a pretty nice calculator. So this is what I asked it to do, make a simple calculator. And 9 times out of 10, this code will actually run. And I have copied and pasted this code out, and I'll include it from one of the runs, and it makes a pretty nice functional calculator. Okay, let's look at a couple of more interesting things. I have been calling GPT-4 so far, but maybe I want to do something else. We have this thing called Azure AI Foundry. So this is a place where you can use Azure to host your models, to build models, to create models, to fine-tune models, to test models. It's actually pretty cool. And if I just create an instance of that in my Azure account and I go to it, it takes me in here. And this is the original thing that we had with Azure, is that I could deploy these different models. And so here's the model, and I can give them different names, different deployment names. Here's one that does text embedding. Here's my text to speech. Here's my speech to text. I've got some chat GPTs in here. And if I look at different connections, I can actually see different models that I have built up for different things. So let's see if I can find one that's maybe a little more interesting. So this is how I put models in Azure that I can use with my semantic kernel or with anything. I can call these through any kind of endpoint. And that's all great. So I can do things like, you know, look at different models that are available to me. I can talk about assistants, which are like agents. I can do real-time audio, you know, image generation. I've got these playgrounds that I can work with. If I want to fine-tune a model, like I said, I can add some things to the model so that it behaves a certain way. Got a lot of cool stuff there. My actual deployments, these are the models that I can use that are up there in Azure for me. There's also a thing in the Foundry where you can create projects. And this is fairly new. So you create a project and you can do things in there. So, you know, here's a project, and it's sort of a way to group your stuff. And you get a slightly different menu over here. You get a lot of the same stuff. But what's interesting is that if I go in and look at this particular project, I can see I've got an API key here. I've got a URL that I can go to, and I've got some things in here that I don't have in the regular Azure AI. And the reason is that these are all the things provided by Azure that are available to me in Azure. But what if I want to do something that's not in Azure? So if I want to say use DeepSeek, or I want to use Llama, or I want to use something else, well, Azure will also host these for me, but these have to be in a project. So I can host all of the OpenAI stuff in here, but I can also host, if I wanted to say, use a Mistral chat completion model, or a Phi3, or if I wanted to use a model to generate images, you actually can look at all kinds of different things. So I've got this model that I've set up that is DeepSeek, and it's got a different endpoint because it's in that project. So I can use the project endpoint for that, and here it tells me all the information of how I can get to it. So here's the endpoint for that and the key that I can use, and it even shows me how to do sample code for it. So here's a sample, DeepSeek R1. And it's very much like what we've been looking at before. Here, I'm going to use a different builder. I'm going to use a different kernel because I need different functionality. I'm going to build a kernel that is for Azure AI inference chat completion. So this is not an Azure OpenAI like I added above. It's a different kind of chat. So inference is just a generic name for what these transformer models do. And I pass in the same thing. I need to know what the deployment is, and here they call it the model ID, the API key, and the endpoint. And in this particular one, I actually pass it as a URI, not as a string. So that part is just slightly different. But once I have my kernel, it works just as before. So now I can say rewrite the above in the style of Shakespeare, be very brief. This is what at my temperature. So this is what I've used before. And we're going to see how this works going to DeepSeek. So this one's actually hosted in a serverless instance in the cloud. So I don't have DeepSeek just sort of loaded up there. I've got a serverless instance Oops. Still got my automatic function calling going there. Let me comment that back out. And you can see that this model is going to behave by default a little bit differently, but it's just as easy to connect to. I just need to know the endpoint, the API key, and which deployment I want to hit on it. All right. And this is one of the things about DeepSeek. It's one of these thinking or multi-agent models. So it's showing you, in this case, and there's settings to adjust how this works, but it's showing you its thought process. The user wants to rewrite this in Shakespearean style and be brief. Let me start by understanding the right. So it's kind of showing you what it's doing. And it's eventually going to come up with, in the style of Shakespeare, an answer. So again, this is just a very different way. The code is exactly as I did above when I asked about Shakespeare, but I'm using the kernel to point to a different model. So my programming remains the same, but I'm doing something a little bit different. So let's see. Next thing, what about local models? What if I don't want to have all my models hosted in the cloud? So there are lots of places to host models. I like to use Azure because in Azure, I've got this agreement with Microsoft that says what they're going to use my information for. They'll host pretty much any model. We just saw DeepSeek being hosted on Azure. But what if I want to run something locally? What if I don't want to spend a lot of money? So I've got this Phi3 test. Let me go ahead and actually take a look at this. This is in my local drive, and you can see what's here. I just downloaded this model from Hugging Face. So I went there and just said, you know, that's the model I want. Download this thing for me. So let me find that path. Repos. So I literally just grabbed this through Git. And you can see there's different builds of it here. This is the CPU and mobile version. So on this particular machine, I don't have an NVIDIA card that would support CUDA. If I did, I could run this on my graphics card. I don't have one that supports DirectML. If I did, I could run it through DirectML. The one I have is for CPU. And so it's just this set of files, and you can see this is pretty much the model. It's these two files. The data is 2.5 gigabytes, and then there's some instructions and header stuff here. So I'm going to go ahead and load this up, and it will take a minute because it's going to load this model into memory, which is a couple of gigabytes, and then it's going to use the local model. Now, once it's loaded, I can reuse that, and it's going to be much faster, so I don't have the startup penalty. When I'm using models in the cloud, I don't have to worry so much about the startup penalty. That's all handled for me. But you'll see that the memory is going way up, and we're getting into the gigabyte range now, and there's a little over 2 gigabytes. And now that the model's loaded, it's going to ask the question and provide some output for me. And again, this is kind of slow right now because I'm only running it on a CPU and there's a big startup cost. But those are things you can get around in real life. All right, and there is my answer. And you can see here I'm starting to get some errors from running the file locally. Those are things that are being worked on at this point. And it's not something that you really have to worry about. It's going to work. It's just going to give you some informational stuff there, which you can suppress. So again, this is the Shakespeare example. We're just doing that same thing over again. All right, let's do something maybe even a little bit more interesting. Let's use those text-to-speech and speech-to-text things that we loaded up in our builder. I'm going to turn off logging because it's really not useful at this point. It's great for debugging. So I'm going to have it record something. So I've got this NAudio file there that's going to make a WAV file. It's going to access my microphone, turn it into text. It's going to send the text to the LLM, to the GPT-4 chat completion. It's going to answer the question, and then I'm going to do text to audio. So I'm going to actually not only show the answer on screen, but also output it. How many eggs are there in a dozen? Give it an easy question. So again, it's turning this into a WAV file. It's sending the WAV file up, turning that into text. The text comes back to me. I send it up to the LLM to get my question answered. Let's try this again. How many teaspoons in a quart? So you can see that it understood what I said. Then it gets the answer.
There are 192 teaspoons in a quart. This conversion is based on the following relationships. 1 quart is equal to 4 cups. 1 cup is equal to 16 tablespoons. 1 tablespoon is equal to 3 teaspoons. So if you multiply 4 cups in a quart, 16 tablespoons in a cup, 3 teaspoons in a tablespoon equals 192 teaspoons in a quart.
It actually went ahead and explained it to me. Now there are interactive models where I can actually talk directly with the model back and forth and not have to do this in such a procedural way. But this is an example of how to do that. So those are some really interesting things. Remember, doing a recap, that you have functions, which can be semantic functions. They can be functions that you code in C#. And so you've got this new way of programming, and the ability to treat all of that as source code is one thing that's great about Semantic Kernel. You've got this ability to do RAG integrations, and I didn't show it, but you can integrate directly into Semantic Kernel and say, here's your RAG integration that I want to use, and it'll actually go out and do the searches for you. We've got plugins and tools, so you can call your stuff or other people's stuff. You can hook into MCP servers, which have lists of tools that are allowed. You've got automatic function calling. You've got agents. So automatic function calling is sort of the first level of autonomy. Agents are a little bit above that. Multiple agents where they all talk and come up with an answer. That's kind of the hot thing right now. And I only see it getting better. Thank you very much. If you have questions, we'll take them now. Here's your free subscription. So you can scan that, and you'll also get the slide deck. So you'll have it there, and I think it'll be in the chat as well. Talked about code staffing. As you can see us on YouTube. Please fill out your evals. It really helps us. And we'll do questions in the chat. Thank you.